Welcome, one and all, to the Math Magic Show. Here's a question. I got this from somebody on the internet. His name is Blaze. The limit as x approaches 0 of x sine of 5 over x. The question is, how do we find this limit? So we got to begin with something that we know. So what do we know about the sine function? What we know about the sine function is the following. That when you graph it, it looks like, let me do it this way. Okay, there you go. So this is x and this is y, and the sine function looks like this, you see? So the sine function is bounded. This is between -1 here, and up here is +1, like this, you see? So the outputs from the sine function always go between -1 and +1. So then you might say very naturally, but it doesn't say sine of x, it says sine of 5x. That doesn't change anything. If you looked at a graph of sine of 5x, it would look different from this, except this would still be a +1 as its highest value, and the lowest value of sine of 5 over x would still be -1. So you can still use this fact. You can check by a graph if you like. So it's going to look like this. We can say -1 is less than sine of 5 over x, which is then less than +1. You begin with that fact. Now, what can we do from here? Well, our goal is to have an x in here, but right now sine of 5 over x doesn't have x in front of it. So the way to get it in there is you got to multiply everything by x. So just do basically like multiply this by x, multiply this by x, and then multiply this also by x. So when you do that, you're going to have -x is less than x times sine of 5 over x, and then less than x this way. This is a true statement. What can we do with this? Why would we do this? Because now what we can do is we can apply the squeeze theorem. So take a look. We can say the limit as x approaches 0 of this -x would be less than the limit as x approaches 0 of this x sine of 5x. Like this. Oh, sorry, one was it 5 over x rather, 5 over x. And then this would be less than the limit as x approaches 0 of x. The nice thing about the limits on the left and right, I mean these limits right here, like this limit right here, and then also likewise for this limit right here, both of those limits can be easily evaluated by just replacing x with 0. In other words, it would be like saying 0 is less than the limit as x approaches here 0 of x sine of 5 over x, which is the less than, and here you can do this through substitution 0 also. How does this help us? Because it tells us that the limit in the middle basically is 0 also. So you can say that this here is equal to 0. That's it. That's the answer, 0. The nice thing about this question is, look at these steps, right? So let's call this step 1. Step 2, step 3, and step 4. They all have something really important in common. What is that important thing they have in common? Something that could be useful to you, even if your question said like 1 over x or 2 over x. This number up here, the 5, look at it. Look at the whole question, right? Like this 5 right here, it appears only in this one place. But it doesn't determine the limit on the left, and it doesn't determine the limit on the right. You see? That's the mystery. Why is that useful? Because it means it doesn't matter, in other words, whether you have this. Look, the limit, say, as x approaches 0 of x sine of 1 over x, that's still equal to 0. Why? There's a 1 up there now. This number, the 5, it doesn't appear anywhere in the limits. This is just the limit of x, -x. This is the limit of +x. And that controls what happens to the middle. So whether that's a 5 or a 1 or a 10, irrelevant. You see? So this would be equal to 0, same way. You see? Another one. The limit, say, if you did x approaches 0 of x sine of, I don't know, make it 3 over x, still equal to 0. It doesn't change anything. So by using this model here with 5 over x, for example, you basically answer the same question pretty much for any number up there. I'm going to leave it at that. So if all of this is helpful, friends, please remember to leave a like, to subscribe, leave some comments down below, and suggestions for other videos. I like those because I take them and I turn them into videos. So I don't have to think about what to make. You kind of have told me what to make. But that's it. So thank you. Please leave a like, please subscribe. And goodbye from the Math Magic Show.